Good morning and afternoon, everybody. Can you hear me? Can I get a hand up or in the chat? Let me know if you can hear me. Perfect. See lots of thumbs up. Awesome. My name is Kelsey Bond, and I am the General Manager at Electric Avenue. It is my pleasure to welcome you to the Electrifying Opportunities webinar. I'll ask everyone to please hold your questions until the end of the presentation. But now I'm happy to introduce you to our guest speaker, Mark McDonald. In 2001, a newly graduated Mark McDonald thought he was set for life when he landed his dream job at Nortel Networks, which was the largest tech company in Canada at the time. 1 year later, after failing to respond to disruptions in the industry, the company was on the path to bankruptcy, and Mark was jobless. Witnessing a tech giant like Nortel fall due to a lack of foresight and action was all Mark needed to take his future into his own hands. In 2003, he started his first business designing and installing home automation systems, which he sold 3 years later. For the next decade, Mark honed his technical problem-solving skills to help engineers, developers, and electricians design and power spaces all over Atlantic Canada, which led him to merge two companies in 2016, forming Catalyst Sales and Marketing. In 2018, he started a renewable energy company, and in 2021, founded Electric Avenue, an electric vehicle company, charging company that sells both hardware and software. Today, he sits on the board as a strategic alliance chair for the Atlantic Canadian chapter of the Entrepreneurs Organization. He also serves as a sustainable energy advisor on the Community Council for Vita Living, a development company raising the standard of affordable rentals in North America. While his dream job may not have panned out the way he thought, it did set him up in ways he could never have imagined. Mark credits Nortel for teaching him an invaluable lesson about business and life, to never rest on your laurels, and that the status quo is never the option. And with that, over to you, Mark.
Thank you, Kelsey, and you can hear me okay?
We can hear you.
Thank you. I know this presentation is focused around the future of transportation, but I like to start with a story from our past, because this is not our society's first generational environmental crisis related to transportation. It was 1894. The London Times dubbed it the Great Manure Crisis. They predicted that in 50 years, the streets of London would be buried under 9 feet of horse manure. And this just wasn't London that was suffering from this issue. This was all major metropolises globally. And despite fierce debates among urban planners and various studies into the matter, no solution to the Great Manure Crisis was ever found. It was a disruptive technology that solved the problem. It was Henry Ford, it was Carl Benz, it was Daimler and others who introduced motorized vehicles at a mass scale and the mass production of those vehicles. So it wasn't the first time a better technology saved an industry, and I would argue the same thing is happening now with our global transportation system and the greenhouse gases associated with it. For anyone who doesn't know this vehicle, this is the Tesla Model S Plaid. It had a brief stint as the fastest production vehicle ever built. And if we're just looking at straight line performance, it does 0 to 60 in 2 seconds. It will run a quarter mile in 9.3 seconds. It has a top speed of 320 kilometers an hour. It will go over 600 kilometers on a single charge. And you can add 200 kilometers of range in about 5 minutes of charging. It even has boat mode. If you get stuck in a flash flood, it may be able to float you out of there by spinning the wheels tirelessly to get you out of that tricky situation. So from a straight line performance perspective, you get all of this for roughly $150,000 Canadian, or around 100,000 US dollars. If we were going to compare that to its internal combustion engine counterpart to get that same straight line performance, you'd be looking at this, the Bugatti Chiron, who only on its best day can beat that Tesla in a quarter-mile race, and it's at the low price of $4.7 million. So that's the disruptive technology that I think is one of the reasons electric vehicles are here to stay. What are the other reasons? What else is driving this market shift, this market trend? Is it hype? Is it reality? You've probably seen both sides of the story being told, especially in the news cycles lately. But another massive driver is the environmental impact. One of the, for the public, we all have an appetite now, I think, for a cleaner environment. These are nitrous dioxide levels. So if you look at these two screenshots, these are nitrous dioxide levels in the troposphere above China. One is pre-lockdown on the left, one is post-lockdown on the right. These are the COVID lockdowns. China was one of the most locked down countries in the world. And these nitrous dioxide level, these are pollutants that come out of the exhaust pipes of vehicles, internal combustion engines, and they're actually one of the most harmful to human health. We're not talking about the environment as a whole, strictly human health here. So we've already had a taste of what a reduced emission transportation can mean, and no one wants to go back from there. And I think it's one of the reasons you see China adopting electric vehicles now at the highest rate in the world, and also producing them at the highest rate in the world. Another market driver, love them or hate them, I'm agnostic on this, but it's not just our federal government. It's commitments that almost 200 countries have globally made around the world under the Paris Climate Agreement to reduce our greenhouse gas emissions. So here in Canada and the US, we need to be 30% below our 2005 levels by 2030. We've committed to be a net zero country by 2050. And why is transportation on the agenda for these governments globally? Depending on what country you're in, it varies, but the US and Canada are very similar. Transportation represents about 20% of our greenhouse gas emissions as a country. So if you are a government and you have made these reduction commitments, there's typically a couple ways to do it, especially in a technology that doesn't have mass market adoption or economies of scale to drive its price down naturally. So you can either tax the issue or you can incent the problem. Our government has chose both. So some of those commitments we've made is to remove anything but zero emission vehicles from sale in Canada and the US, and there's targets around that. 10% of all new vehicles sold by 2025 have to be zero emission vehicles. And now both countries have said 100% of all vehicles sold have to be zero emission vehicles. This doesn't specifically state battery electric vehicles, but of course, we'll talk more about why those are winning market share right now. There's also incentives for the vehicles themselves. So we've set our thresholds, we're taxing the problem, and we're also incenting the solution, as I mentioned earlier. So we're seeing over $5,000 here in Canada. The US has similar rebate structures. We're seeing over $5,000 put towards the purchase price of a zero emission vehicle from our federal government. We're also seeing provinces offer up to $8,000 as a top up on that provincially, with some caveats. So that's the vehicles themselves. Then we also have infrastructure funding. This is getting quite a bit of news, especially in the US market as of late. But between Canada and the US, in the next 6 years, so just pushed out to 2030, we're seeing about $10 billion in commitments from the federal governments to build out zero emission infrastructure. And that's really the crux of the conversation today. How can we, in whatever vertical you may exist in an industry, typically for us, it's the electrical wholesale and the electrical contracting and electrical engineering side, how can we benefit from these massive opportunities? So government is one, and no question, same as our prime minister, love him or hate him, I'm agnostic, but you can't argue what Elon Musk and Tesla has done to drive consumer perception of battery electric vehicles. And the numbers speak for themselves. Over 2 million vehicles now sold globally, and over 50,000 fast charging sites globally, which they did with their own capital. This was not a combined effort from government. This was Tesla building out infrastructure because they recognized very early on, if you want to get mass market adoption, the user experience has to be perfect, not only in the vehicle, but from a refueling perspective. I always like to talk about this because there's still naysayers out there as far as adoption of electric vehicles. For anyone who doesn't know the Gartner Institute in the US and the Gartner Hype Cycle, it's a predictive indices based on the hype around new technologies and its actual real world adoption. Because if you look at this chart, this is pretty consistent with any technology you see make it to marketplace. You have the early innovators, you have something that sparks it, you have the early innovators, you've got the visionaries, and there's always a chasm that has to be crossed when any product makes either early majority adoption, late majority adoption, and then finally the laggards. These are the 2035, hey, I can't buy my internal combustion engine anymore, who will finally come over. And the problem with any technology, if you look at the Gartner Institute, is so many technologies don't make it past that peak of expectations, the hype around the product. And for us in the industry, I think the easiest comparable technology that we've seen implemented in the last 20 years is LED lighting. If you look at LED lighting as a technology, LED lighting was theorized in the 20s and 30s. Patents were placed on it in the 50s. We saw the high wattage blue LED out of Japan in the 90s. But LED fixtures never made it to mainstream market until the late 2000s, so 2010, 11, 12, 13. Now LED lamps and fixtures are the de facto standard, but the hype around LEDs occurred almost 100 years ago. And I think that's exactly where battery electric vehicles are. This is an advertisement. This is the 100-mile Fritchel electric, all-electric vehicle. In the early 1900s, electric vehicles represented 1/3 of all vehicles on the road. It was internal combustion engines, it was steam engines, and it was electric engines or electric transportation. Unfortunately, with a primitive electrical grid and cheap access to oil, distribution, and dispensation, combustion engines won the day. So they represented 1/3 of all vehicles in the early 1900s. Now let's look at global EV sales over time. Let's go all the way back to the early 1900s. And then let's look at that relative to the Gartner hype cycle around the technology. This technology has been overhyped for a very long time, but something happened specifically here in 2011, 12, 13, 14 that moved us from that trough of disillusionment into real world adoption. And if you look at it and what happened during the 2000s, 11s, 12s, 13, Tesla launched its first mass-produced battery electric vehicle. It was the Tesla Model S. In 2012, Tesla was the most shorted stock on the planet, which meant more people in the marketplace were betting on Tesla to fail than succeed. If we push that all the way out, the 2022 pre-market correction, Tesla was the most valued automotive manufacturer and still is of all time. It was the first $1 trillion market cap automotive manufacturer. Its closest rival, Toyota, was worth 1/5 of its value. And what type of adoption are we talking about? In 2022, around 14 million vehicles were sold. Last year, so 2023 year end, we were at 18 million battery electric vehicles globally. That represents 18% of all vehicles sold. So we've moved from the hype to this exponential compounded annual growth. And that was truly the inflection point. So the point of all this is it's not going anywhere. It's here to stay. The sensitivity analysis around what the adoption rate will be will vary. It will fluctuate, but it will stay within the rails. And I can assure you, in my opinion, electric vehicles are not going anywhere. So let's talk about the opportunities from a business perspective. And I think one thing we need to understand when we talk about electric vehicle supply equipment, or EVSE, we technically are not supposed to call them chargers. The vehicles do the charging of the batteries. These are electric vehicle supply equipment. The first thing you need to understand, depending where you are in your knowledge base with a zero emission transportation infrastructure, is it looks nothing like, and should look nothing like, its internal combustion counterparts. This user experience is a horrible one if you drive a zero emission vehicle or a battery electric vehicle specifically, because you don't want to run your battery to zero like we do with our gas tank, and then once a week, twice a week, every few days, stop at a gas station and bring it back to full. It's a really bad user experience right now. One of the big reasons is the amount of public charging off-highway or off-road infrastructure, the amount of fast charging infrastructure, and then of course the time it takes to fast charge relative to refueling an internal combustion engine. The best user experience looks like this. 90% of all the charging that happens in a battery electric vehicle can and should happen at its destination. Now, the most often destination, of course, is your home. Unfortunately, 40% of Canadians don't own their home. Over 31% of Canadians live in a multi-unit residential building. So they don't get to pick whether there's a charger at their destination. The other reason destination charging is so critical, because the average Canadian only drives 50 kilometers a day. That's less than 2 hours or 30 miles a day, let's say in the US. That's less than 2 hours of charge time per night on a level 2 charger. These level 2 chargers that we're going to talk about in 1 second, some people call them slow chargers. They're significantly better for the battery maintenance. They produce a whole lot less heat, therefore they degrade the battery slower, so you keep your range longer on that battery. The vehicle battery lasts longer, so there's a whole lot of benefits. Also, the cost. The cost to deploy level 2 infrastructure is significantly less than the large fast charging chargers we're going to talk about here in a second. So where are those destinations? They're everywhere. They're at your home, they're at your condo, they're at your multi-unit, they're at your workplace, they're at the fleet depot, they're at the golf course, they're at the hotels, everywhere that your destination is. 96% of the time, what is everybody on this call, except those who are driving right now? Everyone on this call, their vehicle is probably sitting there and not moving. That is an ample opportunity. It's much easier on the grid. It's much easier for the grid to control. There is just massive benefits to deploying a wide amount and array of destination charging infrastructure. So what are the chargers? I'm going to keep it simple and concise, hopefully. One, we don't really talk about level 1 charging anymore. Level 1, the way I remember it for anyone who has a technical prowess on the call, level 1 equals 120 volts, typically plugged into a 15 amp outlet, potentially a 20 amp outlet. The reason we don't talk about level 1 charging is it's not really relevant. Some manufacturers still supply this. It's like a spare tire. You know, it doesn't go very fast if you are trying to get anywhere. It's about 5 to 8 miles per hour at, 1.4 to 1.9 kilowatts of energy, or 8 to 12 kilometers per hour. And the reason it's not relevant, in my opinion, is this. The top 10 vehicles now in North America get over or close to 300 miles on a single charge. So if I'm only adding 5 miles per hour, that's an awfully long wait on a level 1 charger. So what chargers do we want to talk about? Where do the business opportunities lie? No question. This is what I stated earlier. Level 2 charging. 90% of all charging can be and should be on level 2 infrastructure. The way I remember level 2, it's either 208 or 240 volts. It's still AC into the vehicle, so it does rely on the what's known as the OBCC, the onboard charge controller of the vehicle, to convert the AC to DC. It then gets run through the battery management system and charges those batteries along the DC architecture on the bus. So not all vehicles onboard charge controllers can take the max amperage supplied with the level 2 charger, but we see the outputs range from 16 to about 80 amps. Personally, 80 amps is not that practical anywhere in North America for single family homes, because just the amount of service size you need to support a dedicated 2-pole 100 amp breaker isn't widely available. So we range from 13 all the way up to, no, that should be lower, apologize, 2 kilowatts all the way up to 19.2 kilowatts, and we can add about 15 to 60 miles per hour, or 24 to 100 kilometers an hour with this charger. And that's what I was saying earlier. If the average American only drives 30 miles a day, the average Canadian only drives 50 miles a day. That's why this is the best infrastructure to deploy. Then we get into the last category, which is DC fast charging, which was known as level 3. When it was level 3, the way I remembered it was level 3 equals 3-phase. Typically what we see in North America is either 208 3-phase or 480 3-phase. There's a few 600 volt 3-phase chargers out there. but they're typically just using step-down transformers to 480. What type of power? We see these all the way up to 360 kilowatts, 400 kilowatts. People are constantly announcing higher outputs. Not that the vehicles can take them, but they can do more shared charging on these public infrastructure deployments, hopefully to lower your total installed cost for that power level. About 200 miles of range in 15 minutes, 320 kilometers for the Canadians in the same amount of time. And then the last opportunity that I'm just going to graze over because the standard has not been ratified or finalized. We just got back from the Consumer Electronics Show in Las Vegas, and we did see a few manufacturers toting this product, but this is the MCS standard. So level 1, level 2, DCFC, and now we have megawatt charging systems. So everything we focused on before really is going to become the go-to infrastructure, or is the go-to infrastructure for light duty vehicles. So once we get into heavy duty vehicles and transport trucks like you see here, they're going to need significantly more power. The MCS standard goes from 750 kilowatts all the way up to 3.7 megawatts in one cable connector assembly. These are liquid cooled. They typically have supplementary battery storage systems at the sites to manage that grid demand. Pretty impressive, and still exciting to see where this is going to go. And the last thing I want to talk about technically, before we look at the opportunities a little more, is the standard which is known as OCPP, Open Charge Point Protocol. And the easiest analogy for me is the cell phone industry. Probably everyone on this call either has one of two operating systems on their phone or two pieces of hardware, a Google or an Apple phone. And just like I can take my Apple phone and I can buy a Sprint version of that phone, I can buy a Bell version of that phone, and I can switch carriers. They're all interchangeable now. My number can be ported. I can go to Mexico, I can go to China, I can go to Europe, and that phone will roam carrier to carrier seamlessly. It wasn't always like that. At one point, they used to lock the hardware and the phone numbers to the carrier. But just like the cell phone industry uses a universal protocol, the EV charging industry has settled on the same thing. And that protocol is Open Charge Point Protocol. And I'm not going to get into the technical details of the control set that allows software to control the actual EVSE. I just want to tell the story of it and its practical function. And this was a letter that Pauline Richards, this is Pauline Richards, she wrote a letter to Electric Autonomy Canada. It was an open letter, and I read through it. And this is actually a photo of her. This is the first electric vehicle she ever bought, the Chevy Bolt. She had just retired, was really excited to make the transition to a zero-emission vehicle. And her first road trip was going to be from Waterloo, Ontario, could have been Guelph, somewhere in Ontario, to St. John, New Brunswick. So she buys the vehicle, she calls the dealer, says, hey, ready to make this trip. Is there anything I need to know? The dealer at the time, as educated as they were, recommended, hey, Flow is a really good network. You can download the Flow app and you can use the Flow chargers. You should be good to go. So she admits she wasn't that technologically inclined, but she decides to test it out at her local charger. And it has nothing to do with Flow, this experience. It was just part of the story. She goes to the local charger, can't get her app to work. She calls Flow. She said they had amazing tech support. And they said, hey, we'll ship you an RFID card. It'll be much easier to start the transactions on your road trip. Orders the card, doesn't come before she leaves. So she leaves on a Friday. She's driving on the 401, pulls over to her first fast charging station off the 401. It's an en route station. Pulls up, can't get the Flow app to work. Turns out that charge point was not managed by Flow. It's managed by another network operator called EVSE. So she had already preloaded $50 on the Flow app, downloads the EVSE app, preloads some money, is finally able to start her charging session, gets into Quebec, said, perfect, Flow's based out of here, tries to start her session at her first fast charging stop in Quebec. Unfortunately, the Flow app didn't work. She had to download an app called Circuit Electrique, ends up getting that going after another app, topping up more money, gets into New Brunswick, gets to an Add Energy charger. She just figures, oh, I better download the other app. Now that one would have worked, but she ended up downloading another app, makes it to St. John, stops at one more charge point station on her way back, has to download another app, load more money, start the session all over again. And she gets back and realizes that user experience is really going to kill mass market adoption. And that is the current problem with the OCPP standard that we all use. It's 1.6. There's a new standard coming out, or that is out and has been finalized, 2.0.1. And I'll just touch on it from a practical perspective. What's the practical difference? If you look up here in the top left corner, the story Pauline told, the issue is we have really robust communication from here, the EVSE, to the cloud software that controls it. We have very limited communication from the vehicle to the charge point. In fact, the only thing we get is a DC pulse width signal that says, hey, give me 16 amps, 32 amps, 48 amps. It's just an amperage request from the vehicle. We don't actually know the state of charge on the battery, how much energy is in the battery. We can't really do much with the connection to the vehicle. And that's why Pauline had to download all the apps and initiate all the charging sessions at the charge point. 2.0.1 was designed to solve that problem. With 2.0.1, as long as you get a vehicle that's built to the ISO 15118 standard, the International Standards Organization, now it moves the payment processing upstream. So instead of getting that simple pulse width signal from the vehicle, now I can get a secure token with the credit card info. So if I buy that Ford Lightning, I put my credit card info in my Ford Lightning, I plug into an OCPP 2.0.1 compliant charger with my ISO 15118 compliant vehicle, and now I get to do what's called plug and charge. And Tesla set this gold standard. Tesla builds the cars, they build the charge points, and they build the app that interfaces the two. If you drive a Tesla right now and you plug into a Tesla charging station, it is a great user experience. You plug it in, you walk away, you get billed automatically. That's what the rest of the marketplace is chasing. And that's why it's so important for anyone on the call on the designing and specifying of this equipment that public charging is compliant with the newest OCPP standard. So how big is this market? I promise you the business opportunities of it. How big is this market? In my opinion, it is absolutely staggering. If we looked at predicted chargers by type, and we look at just the next 6 years, so we push it out to 2030, and we look at level 2 charging, we look at all of the applications I referenced earlier for level 2 charging, we look at all the DC fast charging infrastructure, and then we look at the cost to deploy that infrastructure, the engineering cost, the any groundwork that has to be done, all of the transformers, the pipe, the wire, the breakers. I'm talking total cost of deployment. $9.2 billion will be spent in Canada in the next 6 years, and $97 billion will be spent in the US. And as I mentioned before, there's already about $10 billion allocated to subsidize these costs by both government. And what I find interesting, if you are trying to make decisions around businesses and opportunities in this space, is volume and costs are two very different things. So this is strictly looking at the volume of chargers, where the chargers will be sold. So if you look at single family residential, about 46%, these are the Canadian numbers, but it's very similar to the US. About 46% of all of EV chargers that will be sold are very cost-effective level 2 home chargers. Then we get into multi-unit residential building. We talked about that before. Massive opportunity for level 2, 31%. Then you get into commercial and fleet, another 13%. And then the smallest market category by volume, so total number of chargers to be deployed, is DCFC, so direct current fast charging. So those are just the numbers of chargers, but let's look now at the cost. All of a sudden, single family looks like a great opportunity, but it only represents about 20% of the money that will be spent in the marketplace. MERB gets bumped up to 22%, commercial 16%. The most staggering one in this pie chart should be a no-brainer. It's DCFC. You're going from a $1,000 residential charger to 150, 250, could be $1 million deployment for one charger in some of these new power classes that are coming to market. So that's really the mix of where the opportunity lies. The other thing I think that's important, depending on where you are in this business, is the software as a service and the automatic recurring revenue associated with it. As soon as you get into MERB high rises, commercial applications, fast charging, anyone who wants to track and look at, say carbon offset selling, now all of a sudden you need a software subscription to be able to do that, or the monetization of your chargers. So SaaS all of a sudden pops up as a cost that's not really associated with the volume of chargers that are going to be deployed. Where do we think there's some great market opportunities? Anytime you can get into the private sector, I think from our experience, is an easy one. It's where we've had the most success as a business. But apartment complexes, no brainer, especially when you're dealing with private developers and private or single decision makers. You're not seeing the tenders that you would on some of the public projects. Condominiums, a great one. Workplaces, even businesses you all deal with now, electrical wholesalers, prime example of a workplace that's going to need a robust EV infrastructure. Those business parks, Airbnbs, I think hotels and Airbnbs, those are great ones. Typically you have hotel operators. Airbnb now has a filter function. So when you're selecting your Airbnb, you can select one that has EV charging infrastructure. School boards, secondary schools, private schools, all of those are great opportunities. And then fleet. Fleet, I think, is one of our sleeper markets that's out there for fastest way to deploy high numbers because of the fleet conversion that are going on, especially at the federal, municipal, and provincial level. I know it's harder to bid these projects sometimes, or your odds of winning are lower, but if you look at fleet as an application, especially the ones who are moving fast in fleet conversions, taxis, rental cars, government-owned depots, utilities, waste management, warehouses, distribution centers, delivery companies, just wrap your head around quickly the amount of delivery vehicles that are out there, not just the fleet vehicles. So how do you go and win some business a whole lot quicker than you could do it without some support? The biggest one is the funding opportunities. So in the Canadian market, I mentioned it earlier, we have the Zero Emission Vehicle Infrastructure Fund, ZEBIP or ZEVIP, depending on where you live. Just under $1 billion, so $750 million, $700 million. There is a 2027 deadline on this, so we'll see if it gets pushed out. But they're looking for 700,000 chargers to be funded by 2030. Covers 50% of the total project cost and 75% for Indigenous communities. Under the US, we have the CFI, the Charging and Fueling Infrastructure, and we also have the NEVI plan. Now, these are federal programs typically redeployed, and there's budgets put in place at the state level to redeploy these funds to make sure that charging infrastructure is in place to support the adoption. And we're always happy to talk more about funding, how to access funding and assist with any funding applications. That's definitely one of our strengths as a business. The next thing I want to talk about, and it's similar, we're going to look specifically at multi-unit residential buildings because this really wraps up everything you, in my opinion, need to know about charging infrastructure and the control schemes used on that charging infrastructure. So if we just take MERV as a snapshot, but also apply fleet applications to it as far as these high volume charger deployments, I think you should get a good perspective on what's needed to add charging infrastructure to existing electrical services. So let's start with MERV, multi-unit residential buildings. We're going to look at two specifically. One is low rise. So low rise for us is typically defined by 5 stories or less. This is when the meter stacks are in the parking garage. If your tenant or condo owner meters are in the parking garage, there is a very cost-effective, simplistic, non-software-based control mechanism to support these deployments. And that's known, there's a few companies who make them now, but we're familiar with RVE DCC out of Quebec. And they make a product that allows you to overload the electrical service. This is their DCC 9. So you tap in to the meter in your electrical room, which is located in your underground parking facility. And you can split out up to, let's say, a 2-pole 50 amp breaker, so a 40 amp charger off of that. And it uses current monitoring. So it just monitors the power going to the panel in that condo owner or tenant's electrical service in their suite. And if ever you're approaching 80% of the breaker rating, so let's say you had a 100 amp panel, it sees the amperage on that line draw up to 80%, 80 amps. It just opens a relay or contactor and kills power to your charger. The beautiful thing about this for the apartment owner or the condo owner is they get a very similar setup to a single family residential building. They get a NEMA 1450 plug. So that same plug I referenced earlier, they get a NEMA 1450 plug, a stove plug at their parking location, and they can just plug in their own charger. And then all the energy that's consumed in their electric vehicle is billed to their existing utility bill. So no need for a software-based billing system, no need for advanced control schemes. It's a very simplistic, cost-effective way to deploy infrastructure in low-rise multi-unit residential. Then we get into high-rise. Very different story with high-rise infrastructure, which is the majority of multi-unit residential buildings by volume. Once you get into high-rise, you no longer have the meter stacks in the underground parking. Typically they move for cost reasons and deployment reasons, total infrastructure cost. They move the meter stacks up to the floors. So maybe you'll have one on the first floor, the third floor, the fifth floor, and they split between floors to run the services to the individual suite service panels. So two products, two applications to use there. One, if you are a condo, I still think this is a great option if you really want that same use case and experience as we just looked at previously. One, they make smart breaker panels. There's a few companies that make these, and this allows you to tie a group of chargers to your house power, because now we're moving from tenant meters to the building meter, and you want a way to recoup that energy cost. So they do have smart breaker panels. I don't know if smart's the right word. They're pretty simplistic. It's on or off for that charger. They do some monitoring, managing, but the experience, especially for condo owners, is nice if you want to bring your own charger, because they get that same setup as we looked up at before. They get an EMA 1450 in their parking stall, and they can bring their own charger. So a very easy way to do it. But the more common and the more typical way to do high-rise infrastructure is still with OCPP commercial chargers, especially with the price of these now approaching the same price as you'd pay for a standard home charger. So with the OCPP compliant charger, you end up with the standard electrical panel. So electrically, you wire the building the same, and then you deploy those OCPP smart chargers. And this allows you to do things like monetization, so you can bill your tenants or your condo owners for using that power on your house meter. You get user access control. So if you have a mix of public and private parking spaces, you can control access, you can control when those chargers are accessed. You can set different billing rates. So tenants pay one rate, general public pays another rate, guests can pay one rate, owners can pay another rate. But more importantly, when you get into OCPP smart chargers, you get into some incredible load balancing options. If we go back to the start of the presentation, when I talked about the distance the average American and Canadian drive a day, you'll notice 30 miles, 50 kilometers, we talked about it, level 2 charger, that's only about 2 to 3 hours of charge time per night. So if I come home, and this is why I'm saying multi-unit residential or fleet, if I come home at 5, 6, 7, 8 o'clock at night, and I don't leave the next day till 6, 7, 8 o'clock in the morning, why would I dedicate one 2-pole 50 amp breaker to one 40 amp charger? I only need to be plugged into it for about 2 or 3 hours, but I have a 12-hour charge window. Same is true of fleets and depots and other applications. So how do we share that available power without getting into expensive and costly service upgrades? Well, when you get into OCPP-based, cloud-based smart load management, you get a whole bunch of really neat features. So the most common way is at the circuit level. So I'll put 4, let's say 48 amp chargers in this scenario on one 2-pole 60 amp breaker. First car plugs in, gets 48. Software recognizes it. Second car plugs in, 24. By the time we get to that fourth car, they're each getting 12 amps. Now, for the tenant or the fleet operator, they don't care about how the vehicles got back to 100%. They just want a great user experience. When I come home, I plug in, and then when I wake up in the morning, my vehicle is charged back to my limit or what full is, and I'm ready to go. You don't really care how it gets there. For the building owner, you don't have to get into expensive service upgrades. This is the most simplistic way to do it at the circuit level. You can also do it at the panel level. So you could have each charger on its own dedicated breaker, and then you could set your threshold not to overload that panel. You can also do it by phases. So software can see phase RST, AB, BC, CA. So now we're getting to phase-based load balancing on these 3-phase commercial services for fleets and apartments. And then what I think one of the best load control schemes is out there is current monitoring. So what we would call true dynamic monitoring. So now I can put current transformers either at the switchboard on the feeders or a sub-transformer feeding my electric vehicle equipment. And now can I not only overload the panel based on its fixed breaker value, but I can overload the service because I'm going to throttle the energy to my EV charging network in real time based on the demand on the building. Because when do most people charge their electric vehicles? in the evening. And when is building demand, or even on the fleet applications, if you're a federal or provincial government building and you're only working 8 to 5, when is demand low on that building? In the evening. You're not cooking, you're not doing laundry, you're not doing dishes, TVs aren't on, lights aren't on. So there's typically a large amount of available headroom relative to the service size on that building to charge your vehicles. And this is really how we can deploy large amounts of infrastructure without some of the large costs associated with. So to close out, where is this all going? This is all about electrification. I just want to touch on DER, or what utilities term DERMS, distributed energy resources or distributed energy resource management systems. If we're going to reduce our greenhouse gas emissions to the levels that we talked about, we currently need to go from 19% of all consumed energy in North America coming from the electrical grid to 80%. If we're going to hit those 2050 net zero targets, we need to move 19% of all consumed energy to 80%. That's a huge increase on our electrical grid. If you showed Alexander Graham Bell a modern cell phone, what do you think he would say? If you have people just look at their phone right now and you showed that to Alexander Graham Bell, what do you think he would say? He would have no clue what happened to the telephone network he left behind. In fact, developing countries don't even deploy plain old telephone systems the way we did in North America. If you showed Edison, Westinghouse, and Nikola Tesla the current electrical grid, and you showed them exactly how we distribute energy in North America today, you know what they would say? Perfect. It looks just like I left it. Utilities catch some flack sometimes about change. It's either slow or no, but in fairness to them, it is a critical piece of our infrastructure with some safety concerns associated with it. The good news is, to electrify the entire transportation system of North America, we only need about 15% more grid capacity. We need about 5% by 2030, 15% to electrify the entire transportation system. So it's not that much more energy to reduce that threshold we talked about earlier, which is 27% of greenhouse gas emissions coming from transportation in North America. Because you have to remember, our grid capacity was built for Christmas and Easter. Everyone's home cooking dinner, heaters are on, they're doing laundry. The grid is built for this peak capacity. So if you turned on every peaker plant, or what are known as peak demand response plants, it's only 15%. But sometimes math and reality don't line up. This is one of my favorite stories from last year because of the humor associated with it. But this is August 24th. This is the New York Times, August 24th, 2023. California to ban the sale of new gasoline cars. This was big news because it was legislated. It was put into law. It was no longer a standard. It was legislated. In the state of California, they were the first to do it. You cannot sell, legally, you cannot sell an internal combustion engine after 2035. That was August 24th. And here's the best part of the story. I don't know if people remember this or not. September 1st, here's the same New York Times. Amid heat wave, California asks electric vehicles owners to limit charging. I just told you we only need 15% more capacity to electrify the entire transportation system of North America. Here we are last year, and vehicle owners were asked not to charge their electric vehicles during that heat wave. And this is the interesting part for me. In that moment in time, in the state of California, the grid peaked at 52,000 megawatts. The state of California already has DERMS programs in place, or demand response programs in place. So they sent out a notification. When this grid event was going on, they sent out a notification to EV drivers. Keep in mind, there's 1.13 million EVs in the state of California at the time. They sent out a notification on this distributed energy resource management program. They said, hey, EV owner, we're going through a grid event. Do you want to lower your charging, delay your charging, stagger your charging? And we'll actually sell you the energy at a reduced price. So that's the nature of these on-demand programs for demand response events. What do you think 80% of the people in that demand response program said when they saw a notification from their utility, grid events going on, will you delay your charging? 80% of the people, it actually exacerbated the problem. They chose to top up their vehicle in that moment. And what really matters is the grid peaked at 52,000 megawatts. There was over 28,000 megawatts of stored energy in those 1.13 million EVs in the state of California with no way to get them out. So over half of the energy needed in the state of California in that moment was already stored. And that's where technologies in the short and long term, like bidirectional charging, will become a go-to de facto standard for all EV manufacturers and anyone in our space who's deploying infrastructure around North America. This is a shot right from Ford's website. And this is when they launched the Ford Lightning. It was the first I remember to really launch and advertise it. This is bi-directional charging. So what's known as V2X, it's actually covered under that same ISO 15118 standard we talked about earlier with the OCPP. Bidirectional charging allows you to do two things, V2X. So V to H is vehicle to home, or V to G is vehicle to grid. And that's why, one, we don't need that much more energy, because if we can control when the vehicles charge, utilities love electrification, because now instead of getting these peak events, if we can control when the vehicles charge, we can actually stabilize the grid and have more consistent production on our grid. And two, in the event like we saw in California with that heat wave, if we can draw the power back as stored energy and incent the homeowners, consumers to do that, now we have a new way to get energy without producing more macro production facility, which I can assure you nobody wants to do. And in closing, for anyone worried about the equestrian industry, I know I was pretty harsh on it at the start with the disruptive technology. Today, the equestrian industry is still worth $300 billion. And I think internal combustions definitely have a home and a place in our future. I just think zero emission vehicles are a far better solution. Thank you.
Thank you so much, Mark, for sharing your invaluable insights and expertise on EV charging infrastructure. I know I'm in it every day, but I still take bits and pieces away every time. I'd also like to thank everybody for joining us today. I hope you found the information valuable and applicable to the work in your field. We have left time for questions, so please write them in the chat. We'll do our best to address as many as possible.
Kelsey, is there any questions in the chat?
There are no questions in the chat right now. There is a comment from Mike. The DCC system helps to avoid overloading the electrical panel and unit electrical service. However, it does not monitor the main service. The main service to the building may need an upgrade. Do you want to comment on that?
Yes, Mike, there is a product that we've seen through DCC. It's a Crystal Controls product. It's the LS100. It's the LS100, and it has a CT monitoring capability for services because of the way you have to rate those condos and apartment buildings, the service sizes, but it will send a control signal. So you can shut down blocks of DCC. So I think you may want to check with DCC. It's not our product, but I do think they have a solution for that now, Mike.
There is another question here from Sandra. Did Mark say at the beginning that electric cars are not going anywhere?
Like figuratively or literally? Literally, they're going places. Yes, figuratively, they're here to stay. I don't know what I said. I said a lot of things. That's all I know.
Thank you. And then a question from Peter. Any thoughts on the carbon credit program currently and longevity?
My only thought is that we are approved as a network operator for the CAT system, so the credit and tracking system. So right now in the Canadian market specifically, about 50,000 kilowatt hours will get you anywhere from 7 to 10,000 in offset credits. So we are approved for it. As far as longevity goes, it's equal government. So as long as the Liberals are in, I guess it's in. But yeah, that is beyond my pay grade to speculate on where it's going to go. But I will say we are approved as a network operator under the carbon credit and tracking system with the federal government.
Okay, and then from Bid, what is being done on EV range and battery technology to combat the issues seen more prominently with cold?
Great question, especially for our Northern Americans and the Canadian marketplace. This is not my field of expertise. We were at a conference not too long ago, and the analogy was made by one expert in that space that, we're still early days. We talked about the horse and buggy relative to the internal combustion engine, and it's very similar. If you look how far the internal combustion engine came in the last 100 years, we're still at the very early days of battery technologies relative to zero emission vehicles and mass transportation. So the consensus among experts seem to be range will only go up, charge time will only go down, and these conversations will be mute at some point in that technological advancement and development. But yes, there are definitely range issues right now, especially depending on how you heat it. I'll be totally transparent. We have a Ford Lightning in our fleet. We also have some Teslas. That Ford Lightning that we have uses a resistive heating element as opposed to the Tesla, which uses an air-to-air heat pump. And the Ford definitely suffers in cold temperatures. And we're in Halifax. I know there's significantly colder areas in the country that range would degrade even worse in cold weather.
And then a question from Farshid, is the building manufacturers aware of the new requirements for EV chargers? When will it be in the code for building manufacturers, if it will?
That's a great one. We've only seen it. I actually took a read through some revisions, proposed revisions. We sit on the EVSE committee for electric vehicle infrastructure, and I saw some revisions today, but we've only seen it really at the municipal level. I think one of the most mature in building code requirements around EV charging infrastructure is municipalities in the province of British Columbia. Actually, the city of Vancouver funds what's known as the EV Ready Plan. So if you are a building manufacturer, or you're building a building, the city will pay essentially the entire cost to have an engineer get involved and design that building to be up to 100%. and may be required now to be 100% EV ready. And they actually require the load balancing schemes I talked about earlier. So they would not allow you to design electrical service where it's a 1-to-1 ratio of chargers to circuits. So they don't want those rated at 100% capacity. We've also seen, I think just recently, the province of British Columbia has preemptively adopted the new code guidelines under the Canadian Electric Code under electric vehicle energy management systems, which is a whole nother conversation, but we're only seeing it right now at the provincial and municipal levels with some of the greener states and provinces. We haven't seen anything at the federal level yet, both in the US and Canada. So time will tell, but no question regulatory capture would help move the needle a whole lot faster on some of these infrastructure issues that we are having.
Great, thank you, Mark. There's another question here. Are V2X systems allowed by code in Canada yet? Do you know if this is coming soon?
That is a great question. I can only speak to the technology. I have solar on my house, and again, I mentioned we have a Ford Lightning in our fleet. So from a technology standpoint, it is almost identical to how a solar inverter works. Instead of taking DC from the solar array on your roof, let's say, or a ground mount system, you're taking DC from the battery, and then you're using an inverter to get that back to AC to match grid frequency. So I guess two things would be applicable there. If your province or your utility already had a battery storage program or a net metering program for bi-directional things like solar, then it would probably be pretty easy to deploy. As far as code requirements, I can't speak to that, but there is a big cost to it as well to get that infrastructure in your home. And then if you wanted to go with a hybrid system that you were just using it for not V2G, which is vehicle to grid, but V2H, I don't think that would be a code issue because then you're not actually backfeeding any energy on the grid. You've got a transfer switch there. So when power is out, you don't have to worry about transferring energy back to the grid.
Awesome. And then another question from Abid. Have any charge point manufacturers adopted OCPP 2.0.1 yet?
Yes, so we have a product, we call it the Wadi Pro, that is compatible with the OCPP 2.0.1 standard. Our software backend is also dual compatible with 1.6 and 2.0.1. And you should see a handful of manufacturers now who have the technology built into the hardware. The bigger thing is the software being compatible, and then ultimately getting the vehicles to market that are compatible with that ISO standard so they can actually talk to them. So if you're in the specification engineering or deploying infrastructure and you want to be future-proofed, I would definitely recommend selecting chargers for public, especially that is 2.0.1 compliant, because like I mentioned, there's a handful of companies now that can offer that technology in their hardware.
Great. And then from Asan, are there any plans to have manufacturing started in Canada?
Canada, I would love to. The US just swings such a big needle and has so much clout. So our next plan is manufacturing. Some of our pedestals are now manufactured in the US. Mechanical is much easier. And then our next plan is to manufacture the chargers themselves in the US to keep compliant with the NEVI requirements. So Canada, I will and still do business effectively in the US, but unfortunately, because of their regulations, they're kind of forcing our hand. I think some people who are familiar have probably seen Flow also now manufactures their chargers in Michigan to stay compliant with this US standard. So kudos to the US for flexing their muscles. So unfortunately, our plan is manufacturing in there to support that market as well.
Great. It looks like that wraps up the questions for today. If anyone has any thoughts or questions afterwards, feel free to reach out to us at info@goelectricav.com. But thank you again, everyone, for watching, and thank you, Mark. I would also like to mention there will be a recording sent out after the session, but that is all for today, and we'll see you at the next one.
Thank you.
Thank you.